I'm going to shrink wrap it.
Look, scrappy challenge.
Most heat engineers would think that.
That's right, yeah.
I might just start putting them indoors. We don't have a clue about heat pumps. Neither do you. So no one expected this. If you follow us on Twitter, Facebook or LinkedIn, you may be aware of a post I did recently highlighting the issue, which I believe to be very true, of microclimating. When I posted this, I had a lot of kind of feedback from aircon guys, very respected and good aircon guys, saying this isn't a problem, which didn't fit with my understanding of physics at all. I thought it'd be a massive issue. To clear that up, I thought the only way to do this is to do an experiment, and that's why we're here today, and that's why we also have our newest member of the Heat Geek team, Simon.
Hello!
Hello, how you doing?
Yeah, all good, all good.
Welcome to the Heat Geek team.
Pleased to be here.
You're going to be seeing a lot more of Simon moving forward. Simon's got a load of experience in heat pumps since when you fit your first heat pump?
2008.
So in this picture that I took when I was going for a nice walk on New Year's Day with my partner, you could see if you zoom in on the picture that the walls were kind of the same height as the heat pump itself, which showed to me that essentially all the cold air would stay in that area, right? I mean, most heat engineers would think that.
That's right, yeah.
So with air conditioning engineers, they might be used to the opposite of this. When you're cooling down a building, warm air's blown out, which is lighter than air, which immediately rises and won't sit in this pool. With heating, it's cold air, it does the opposite. So that's why in my mind, aircon engineers might not have thought of this maybe, I don't know, or maybe we're just less experienced. I would add again, I'm not an experienced heat pump engineer. I'm a hydronics engineer, like to think I'm a hydronics expert, and it just so happens that's the most important thing with air to water system to make them efficient. We're actually going to set off some red smoke pellets so you can see the air go through the heat pump, possibly sink because it's going to be colder, and then eventually clear and dissipate throughout this car park, drawing in fresh air at the back. And then we'll do the same smoke pellet test once we've boxed it in so we can see how much difference there is or recirculation there is. It's kind of going up and down, it's not exactly just falling, is it? So, but there's no recirculation, you can see at the back's clear.
So we did actually go to the building, it's a off license in London, near Embankment, to actually measure the roof, the well, the size of the well that the heat pump is sat in. And I'm sure Harrison will put some footage of Adam bending a ladder, getting up the ladder to do the measurements. So
the inside headed out to the location, the proposed location, or the location of the contentious heat pump that may be recirculating. So we've walked here, it's closed, but I'm just going to do it anyway. Wish me luck. So there we are. It's not really leaning any way. It's blowing that way. The distance or the length of this area is 2.7 behind and 4 in front. 2.7 and 4 in front. 2.4 widthways. This isn't on. The air clearance, like there's no wind up here, and it's a relatively gusty day. It's about 8.5 miles an hour wind. Behind me, we've got a lot of tree coverage around here. And tall buildings. And the tall buildings see also slow flow.
So what we thought we'd do is try and recreate that space here at the Vito offices with our heat pump. Cold air sinks, and as the air is the fuel source for an air source heat pump, we want to prove how we are going to lose efficiency by sucking in and recirculating this used air from the heat pump. We're at Vito offices, we're going to use their heat pump, we're going to build some walls around it and see what comes out of it. Let's get building!
Cheesy!
How are we going to do this, Ads?
I don't know, this is not working already. This is not working. I was really excited about this and it's going. This is so much harder than I thought it was going to be. If we could just do uprights somehow, should we have a look in the garage to see what's there?
Let's go and see what we got. This will be better, much better.
I'll take some of these and I can at least see if it's doable with them. Oh, Si, that is wonderful. We're going to try and fix the Corex to these crates instead, and then we'll just lift up the crates and move them as we need to. See how that goes.
Made for it, eh? It's like scrap heap challenge.
And I'll slide this over, and voila. So what we're seeing here on this is it's going up to 1.5 degrees difference between in there and out here, and then it's dropping to about 1, and then it's going up to 1.5, and it's dropping. So it's kind of like cycling in and out, rather than it being the same temperature. You can see that here if you focus on. It's currently 1 degree difference, and that will go up to 1.5 degree difference at some point very soon. I actually got a suspicion that this isn't as bad as if the units were, as if there was more room, because I think it's creating air movement in here that shuffles the air. I think there'll be a bigger differential when we make it bigger. Right, smoke time. You can see the air, the smoke going back round into the back of the unit. Some is getting over the fence, but you can definitely see it going back around. And that's what we want to avoid. We want to avoid seeing any smoke here. When we did this experiment without this stuff in the way, this was a completely clear shot. You couldn't see any smoke at all. Now you obviously can.
That's so much different, isn't it?
It is, yeah. Yeah, it's like hanging around, isn't it? It's not even out here. The smoke's not even here. It was all out here before. Now it's just staying in that area, look. It's suffocating on itself. Let's go and look at Open Energy Monitor. So far, the results are, if you can see this screen that I'm showing you, we put this stuff in place, we put the barriers in place round about here, 11-ish?
Yeah.
So we've gone through this cycle. This cycle doesn't look loads different. It doesn't look like it's having a massive impact. And this might be, I definitely wouldn't say it's a waste of time. This is going to tell me if there's no impact that we can be a bit more risky with where we put our heat pumps. However, I think one of the things that I'm thinking here is fence height. 6-foot fences I think would be very different from 4-foot fences. So maybe 4-foot fences, fine. Maybe cold welling isn't that much of a problem in that, or maybe it is. We'll wait and see. So far, it's not as bad as we thought. So that hasn't shown much difference at all, none in fact. So what we're going to check out now is if we had a 6-foot fence in front and the sides open, like a more typical kind of alleyway scenario. Let's see what happens. So we're doing another smoke test with a 5-foot fence in front of it, but we've still, in front of the heat pump, we've still got the manufacturer's clearances though, so let's see how that works out. And this is very typical for most houses, to have an alley down the side of the house that you squeeze the heat pump in. That must be recirculating, right? I mean, some of it's going over that fence. Should we have a look? On that brown door behind me, you can see smoke like coming down, so the air, cold air is coming over and just dropping down into their drive. Normally you'd have a house on the back of the heat pump, so it wouldn't be able to go back over, which would make it much worse. I'm surprised how much has gone down there though.
But the airflow's probably coming from the road, just
Yeah,
pushing it that
way.
pushing it that way.
Yeah. I wonder if we shut the door. Another smoke test with the door shut?
Yeah, why not?
We don't look weird at all, do we? It's fascinating stuff. That seems worse than before, doesn't it?
That's definitely worse.
So fence height is the problem.
But that's terrible.
Yeah. It's 12:35, 10 minutes after we put the fence in. We've shut the door. Let's go see what that does to our Scott. I can't see any difference there. It's absolutely fine. I stand by the fact that I think when the fan's slower, I think it would be a slight bit more of an issue because I don't think it will stir up the air. But I also think the issue wouldn't be as bad as I previously have assumed. I think when we found these issues, like we have it with the air-to-air back there and on the other job that we've seen, I think that's just that specific condition. We need to think about what those are and how people can avoid them, basically. So bending the air back round to the unit. We have seen in one of our HeatGeek Elite installs, someone installed like this. It's blowing, it's hitting this wall, which is about 6 foot tall. Because the angle of the wall is that way, it's bending the air round. The air's getting here. This is actually a wrought iron gate, so it's an open gate. You would have thought this is a clear pass through for air, and this is open, this is not closed off. and the air is basically going back round, and the unit is struggling to get up to temperature. If you angle the air source heat pump one way or the other way out the gate, it works auto-magically. That is a condition where this is an issue. We haven't recreated any issues here yet. So far, I'm a little bit more positive about how many places we can put heat pumps on a positive note. Actually, this is opening up quite a few possibilities. So what I would propose is if we did this same test at when it's 10 degrees outside and the fan's modulated back to the minimum speed, I think that the air might pool up and create this cold welling, but I don't think it's going to be as bad as I'd have ever imagined before. But caveat, because I know Simon's looking at me strangely, we do not recommend any of these.
We are seeing the air ambient temperature and the air inlet temperature stretching ever so slightly, but it's only shifted by about 1 degree over the whole morning's testing.
Up to 3.
It's up to 3 now, but it was at 2 difference.
Right.
It's now up to 3 with the 6-foot fence.
What Simon's measuring is the temperature outside via the weather compensation sensor by our front door, which is sensing, -2 or something like that?
It's up to about 1 now. Yeah.
Up to about 1.
Yeah.
And then he's looking at the sensor in the back of the unit that's measuring the temperature of the air coming into the back unit, which is 1 degree, 2 degrees, up to 3 degrees lower than the air outside. And how we get the most efficiency is when the outside temperature and the flow temperature are as close as possible, because then the compressor doesn't have to drive as hard. So on paper, it shouldn't be as efficient. We can't recreate it at the moment, though.
We can't measure it, really. I think it's minimal, isn't it?
It's minimal difference. I gutted because I was like kind of looking for an exciting video, but actually really happy because we can decarbonise more homes. But I still want to recreate the
rooftop.
The cold well. Should we give it a go?
Just find some more material.
Come on, mate. Si's made a judgment call, a correct one. We're not going to recreate that photo. We're just going to try and force this heat pump to not be very good. If we can't force it to be bad, it makes heat pumps amazing. So we're going to just close this off again and have higher sides and just try and force this heat pump to be as poor as possible.
Oh, it's cold in here.
This is within manufacturer's clearances. So the manufacturers think this is going to be all right. We wouldn't have thought it would be, but what do we know? F all by the looks of it. Oh, what the f are we doing? That's where we keep Simon. You're all right there, aren't you, Si?
No! Time is nearly 2 o'clock.
So now we're inside the manufacturer's clearances. We've put a 5-foot fence around instead of the 6-foot fence, which is the fence behind, you can see. The difference has dropped to, it's 2.4 degrees out here and it's -3 in there. So there's a 5.5 degree difference. 5.6 degree difference between in there and out here. So this is immediately spiraling. We're going to see loads of results in there. So wall height does matter, does make a difference. We'll still do the smoke pellet test. If you light up the smoke pellet now, Si, you can see it. I don't know if you can pick it up on the camera, but it is going around on itself. You can see it looping, yeah. Well, yay. If you really box it and it doesn't work. All right, well, we'll leave this one on for half an hour in the warmth. It's still not cleared. The other ones would have cleared by now, wouldn't they? So let's go and have a look at the open energy monitor again, see if it's immediately done
a Dubry.
Yeah, done a Dubry, exactly. The flow temperature's gone up quite a bit.
But
yeah.
because it's trying to get.
You could just put them in boxes. I think we are going to have to put a lid on this thing. I think we're actually going to put a lid on it to make it not work. Heat pumps are incredible. Which unbelievable. Heat pumps are so good. Look at the copper last 30 minutes. It's gone up to 2.8. Let's go and have a look. What's happening?
There's the lid.
Oh!
There's the lid we're after.
The fan was holding the wall up. When it went when it went into defrost, the fan turned off. And the wall just fell down. This is just the best experiment we've ever done, isn't it? It's oh well. Back to it. Heat pumps are amazing. Amazing bits of kit. Can we not Not to say.
No.
We did an experiment, nothing happened. All right, you guys can go home now.
Yeah. Cut.
There's nothing to say. Like, we can't draw a conclusion. Like, yeah, there's nothing, there's no roundup. Just nothing happened. And if you want more content like this, where nothing happens for 45 minutes, join, subscribe, like, comment, and we'll produce more. So basically, the wall collapsed. We've been in, you've probably seen, we've been in, and 6 foot or 5 foot fence didn't tank the efficiency at all. These walls are now well within manufacturer's clearances, so just see how bad it is. We're just going to chuck a smoke pellet in there, and we're going to leave this on test for an hour to see if we can actually force this thing to be inefficient, because at the moment it's bomb-proof. I might just start putting them indoors. I'm not going to start putting them indoors. I mean, I think that I think it's just going to perform again. I think it's going to be fine. But it should be pulling air from down into there though. Because where else is it getting air from? It's boxed everywhere else. If this works, then they're just bomb-proof. Give it a happy little lid. There we go. Heat pumps quite good, aren't they? I might get one of these actually.
Yeah, these newfangled heat pumps are amazing.
They're actually all right. Looks like a kid's den, doesn't it?
It looks like a rabbit now.
Yeah, it looks like you've
like
just.
a base I would build when I was. Like,
Yeah, it looks like
10
you brought a
or something.
boiler box home for the kids. doesn't
Yeah,
it?
yeah. You know,
Over
just
the
before we
air.
look at this, you know, we tell everyone, no, don't box in your heat pump. We need to see it. We want fresh air moving around it.
Yeah.
Can we box in heat pumps now? Well, look, that's not good, is it?
Zoom in.
This bit here. Let's have a look. So what time do we put it on? About 12. Here we put it on. Like, the heat output is lower.
Yeah.
So it's restricted the output from 6,700 watts all the way down to 6,300 watts. That's fine. Yeah, all right, it's a small guy. It's got the same amount of power input, which is 2,270, same as before, 2,300, basically the same. The heat output's gone down, so we know this, if we take this scop here, or this cop, 2.87 before, and now our cop is 2.74. Gone down 0.1, fully covered up. We don't have a clue about heat pumps. Neither do you. So, because no one expected this. No one expected this. Few caveats that I want to make clear. One, the condition that I showed you earlier where it recirculated, maybe that's much more important to keep in mind. There might be certain wind conditions in certain areas that cause like a whirlpooling effect where, so there are the other things that need to be kind of considered. You could perhaps, if you've got kit like this, the Open Energy Monitor Kit to monitor your system, perhaps you can experiment by diverting the air intake or the air outtake to see if you can improve SCOT. But any thoughts? Wild thoughts?
No, I have no idea.
Sure. Speechless.
Yeah, absolutely.
I was struggling to find things to say.
It's completely covered up right now, and it's still.
Yeah.
It is worse.
It's got a lid on it.
It is worse.
2.74. What's the outside temperature? It's minus 0.3. It's 0 degrees outside. 0 degrees outside, and it's getting a cop of 2.74 with 4 walls around it within the manufacturer's limits and a lid on top. Let's leave this running. You can come back to see this. We'll put the link in the description. The date is the 17th of January. It's currently 20 to 3. We're going to leave this on for an extra hour or two, and you won't be able to tell which part of the graph we've done it on, but that's the time it is now, and it's fine. If we agree that we'll take the lid off at 3. We'll take all the sides off at 3:30, 3:45, maybe 4. Then you might see it jump somewhere, but I don't think you'll notice any difference at all, really. Do you know what we have out there? We've got a massive roll of shrink wrap. Let's do it. We're here with cameras. I'm going to shrink wrap it. I just want to stress that we don't want other people to do this. This is not how you should run heat pumps. So now we've completely covered the unit in completely airtight Corex floor protector. There are gaps, so we've chucked a load of blankets on. A lot of these blankets have got plastic backing to make them waterproof, so that won't let any air through. The cop was 2.47. Let's see what this does to the cup, if anything. So we've gone outside, chucked over the blankets over there, so you can't. There's no air holes or anything like that. The blankets are waterproof dust sheets, so it's it's got plastic on there to stop any air coming through. Or one of them's like that. Let's see what the results are. 3:30, 25-minute run. Finally, we got a shorter run. So from 3 till 3:35, cop-in window is 2.6, which is really good. It's a much shorter run. It's only a 30-minute run, which is shorter than the normal 40-minute runs that we get, but it's still performing. Let's include this bit here. Let's do from there to there. 2.38. Okay, it's gone down a tiny bit. Heat output's a bit lower. Well, we put that cover on here, look, and then we fiddled around with it. And I think I probably covered up that bit there. Tucked it in the thing there, so it has reduced it. All right, let's try this bit then. 2.11. Okay,
finally.
We've made it reduced to 2.11, which in this weather is probably the average pour install. Most installs would be done at
7 degrees. Well, at 7 degrees.
At 7 degrees. So like pour installs, that's how they would perform. This thing just keeps running. It's bomb-proof.
The house will struggle.
The house is cold.
Will struggle for comfort because your mean energy input is lower.
Exactly.
Lower,
Yeah. So
because of the more frequent defrosts.
Yeah, but again, cop-in window 2.4. If you've got an oversized unit, probably fine. We don't have an oversized unit. If anything, actually, that's undersized. So despite the fact that we found almost no difference whatsoever, don't go covering up the heat pumps just yet. When the weather's warmer outside than -1, the fan will probably be moving about half the speed and there'll be less turbulence mixing up the air, which might make the heat pump performance stay at 2.5, 2.6. And really in that scenario, it should be up at a cop of 4 or 5. We will do that experiment again in the future, and we'll put it under even more stress than it is right now. Perhaps wrap it in cling film.
So if you think you're getting microclimating on your heat pump, the way to sort of check it and make sure it's not occurring is you can measure the outside air temperature using the weather sensor and also check the air inlet temperature at the back of the evaporator of the heat pump, and we would say it's starting to occur anything over 1 or 2 degrees difference.
So the air inlet to the back of the unit is 1 to 2 degrees below the outside air temperature.
That's right, yeah.
Hi guys, just watched the video edit, which I thought was quite an interesting one. A couple more thoughts I just had now are that clearly the cover that we've covered the thing up with is allowing heat transfer through because it's not insulated. So any buildings that are more insulated might have a worse effect on the temperature tanking. So that's worth bearing in mind. And the most important lesson I'm taking back from this actually is typically for efficiency, we want the source, the outside air temperature, and the sink, which is the radiator temperature, to be as close together. The closer together they are, the more efficient it could be. What I'm potentially learning from this is the outside temperature matters less than the flow temperature. So 2 things from that. 1, the outside temperature does affect the amount of power that we have available because it's going to mean more defrosting potentially. But more importantly, it is the flow temperature that drives our efficiency mainly. And argue again in the comments if you disagree. I'm totally open for debate, which is where we will learn. It's all about the peer-to-peer. Please get involved. But most importantly, again, it's not the box outside that's important. It's the internal system design. And that's exactly what we teach here. It's all about system design. It always has been, always will be. It's just that it's never been fully appreciated. And I think that tide is now turning. So yeah, please, if you've got any comments on here, there's many of you out there that know a lot more about heat pumps than me. Please get involved in the comments section below and share your thoughts and get involved in the ecosystem, which is Heat Geek, where we share and pool knowledge together and all become better as one. Okay, thanks for watching. Hopefully you didn't get too bored watching nothing happen for the last however long this video turns out to be. It's goodbye from him.
And it's goodbye from me.
Subscribe, like, comment. See you next time.